Hi everyone, we're talking about the length of an arc on a circle, and we're talking specifically using radian measures. And it turns out that if you think back to earlier in your high school experience, to find the length of an arc in degrees, you had to do the following. Using degrees, you'd have to go L is equal to, you'd have to do theta over 360 to work out the proportional circle times the circumference. So you basically are saying what fraction of the circle we're talking about, theta over 360, because 360 is the whole, and then multiply it by the whole circumference, which is 2 pi r. However, if we're in radians, we don't have to do that anymore. We simply have L equals r theta, as in the radius times the angle in radians. Theta in radians, it has to be. All right, so that's just to clearly make that up. So that gives us this arc length. Now, you would have seen in introductions about radians that if that unit length is the same as r, then it means it's 1 radian in the center, and that makes sense. R times 1 gives you r, so the length of the arc would be r as well. Now, just a definition, we say that the angle is subtended by the arc. So if our arc, you connect the two endpoints of the arc with the radii, and you kind of make a shape of a pie or a piece of pie or cake, we say that the angle in the center is subtended by the arc. So let's have a look at a couple of examples. First one's kind of straightforward, most of them are really. Find the length of an arc that subtends an angle of 2 pi on 3 radians on a circle with radius 4. So if we were to just draw a circle, drawing diagrams to give us a sense is generally a good idea. We have the center here. That's my 4 centimeters. Now 2 pi on 3, now this is just an activity of continuing to think about it. So 2 pi on 3, that's equal to, and remember what you have to do, you have to multiply that by 180 over pi. To change it to degrees, just so you know, that cancels out the pi if you want to think about it like that. That's going to be equal to, what's that going to be? It's 120 degrees, and you'll get more familiar with that as you go through. 2 pi on 3 is 120 degrees. So, something like this. This is 2 pi on 3 radians. That's 4 centimeters, and we want to find this distance. So it's a bit rough. I want to find this distance. And so it's as simple as to say L is equal to r theta, 4 times theta, which is 2 pi on 3. Now that becomes 8 pi on 3. And the distance, it's a distance, so it's centimeters. Now we could put an approximately, and if we found what that is, you just work out using a calculator what 8 pi divided by 3 is. 8 pi divided by 3 is equal to, well, that's not right. Oh, it is 8.38 to 2 decimal places. There you go. So that's very straightforward. You have the radius, you have the angle that's subtended, you can work out the arc really easily. Now let's have a look at the next question. In this one you really do need a diagram. A circle has a chord of, remember to underline key features, 25 millimeters, angle of pi on 6 radians, subtended at the center. Find to 1 decimal place the length of the arc cut off by the chord. So we're actually talking about a chord to start with, and we need to find, this is defined, the length of the chord. So I'm going to draw my diagram first. Okay, so we've got that. So we've got 25 millimeters, I'll mark the center, 25 millimeters, 2.5 centimeters. Now pi on 6 radians is equal to, it's 30 degrees. Again, you multiply by 180 over pi, and you see that it's going to become 30. So I could mark that, but that's just, if you're not sure, it's a good idea to write it somewhere, if you, particularly early on, to get a better sense and to keep practicing. So that's 25 millimeters. Okay, I've taught that wrong. Instead of starting again and doing a whole nother video, I'm just going to correct what I've said. You may have picked it up already. All I know so far is that the angle in here is pi on 6. I don't actually know, and that's a good thing I picked it up, the chord is 25 mils. So here we go. I'm going to do the chord in pink. So we want to find this chord, and that's 25 millimeters. Okay. Now we don't know what R is, so I'm going to just put R. And so the goal is we want to find L, right? Which I'll put in green. We are trying to find this distance, L. So to do that, we know the angle in the center, but we need to know R as well. But here's the thing, is that if I redraw the triangle, we have basically something like this. Pi on 6, R, 25 mils. Now, this is an isosceles triangle, and so I can actually work out what these two angles are. Now, I'm going to do it in radians. If you're doing it in degrees, it's going to be 180 for the angle sum, minus 30, so that gives you 150. So it's going to be 75 degrees. Now, I'm going to do it in radians. So in radians, it's going to be pi minus pi on 6. That's going to give you the angles, the two angles here, and then we divide it by 2. And that gives me pi minus pi on 6 is 5 pi on 6, divided by 2 is 5 pi on 12. Okay, so we've got 5 pi on 12. Now what I can do is simply use the sine rule. And so, use the sine rule, which of course is 25 over sine pi on 6 is equal to R over sine 5 pi on 12. So if we work this out, we're going to have R is equal to 25 sine 5 pi on 12 over sine pi on 6. Now this is going to give us a reasonably accurate answer. So I'll type that in. Now you've got to make sure that your calculator is in radians. Either it's going to have a rad at the top, or you have to press Shift Answer if you have a Casio and select 2, which is how we change it. You've actually got to go into Comp and change the settings. If you press Shift Setup and then press 4, you'll change it to radians. 25 sine of 5 pi over 12 divided by sine of pi on 6. And that's equal to, I get R is equal to 48.296, and that would be millimeters. So we're going to work that out. The question's saying length of the arc cut off to the chord 1 decimal place. So once I have that, I can work out L, which is equal to 48.296 times the angle inside, which is pi on 6. And so that becomes 25.288 ... which is equal to 25.3 millimeters to 1 decimal place. Now you notice that it's actually very close. Because the angle's small and it's a small triangle, a small circle, the length of the chord and the length of the arc are very close to each other. It's just slightly longer because you have to curve around from one point to the next. Anyway, we're going to try exercise 6.2 and see how we go. There's an equivalent one in the extension book, which is chapter 5. Chapter 5 in extension book. Okay, thanks.